Welcome back to Air Quality Matters. We already have the tools and knowledge we need to make a difference to the quality of the air we breathe in our built environment. The conversations we have and how we share what we know is the key to our success. I'm Simon Jones, and coming up, the first part of a special series of podcasts from India, where Air Quality Matters was the official podcast partner for the Healthy Buildings 2025 conference in Hyderabad. In parts 1 and 2, we'll be speaking with both the next generation of researchers from the region and industry. It's a fascinating window into what's at the forefront of science, what the next generation of scientists are focused on, and the problems they are looking to solve. But also from industry, the businesses on the ground, innovating, solving problems, and building the sector right now. Many of the challenges are the same. Many are different. What runs between them is a passion and drive to make a difference and share knowledge. I've been really looking forward to this. The Healthy Building Conference and ISIEC event was a really special one, and I hope these conversations can bring you a flavour of that dialogue. I say at the beginning of these episodes, it's the conversations we have and how we share what we know is the key to our success. And this extends globally. To truly understand how to solve the problems we have, we need to understand the full spectrum of the challenges and opportunities that face us. The perspectives on display here will feel familiar, but perhaps offer a fresh view. Don't forget to check out the sponsors in the show notes and at airqualitymatters.net. First up, we have the researchers. This is a conversation in order of appearance. Kumar Naduniri, Sruti Roberts, and Prativa Lamsal.
I really appreciate you taking time out of the conference because I know it's really valuable time down there. So I'm not going to keep you any longer than I have to. But it's a really good opportunity for us to hear from people coming into the industry that they've got some experience, how you found it and what you're seeing and why this stuff matters. So before we get into the meat of it, probably the best thing for us to do is just introduce ourselves to each other. So if we start with yourself, just explain who you are, where you live, and the kind of stuff that you're working on at the minute.
My name is Kumar Nadunuri. So I am from a city called Warangal, which is very near to the Hyderabad city. So I have done my graduation in this very same city, Hyderabad, and I have pursued my graduation on building services and technology. And then after I have worked for some time in the industry, and then I have pursued my master's in building science and technology in Bangalore city. And so after that, I started working as a research assistant in one of the private institute in Gujarat, where I found my research interest, and that is where my research interest in me, turned towards the PhD research. And now I am working as a PhD research scholar at the Indian Institute of Technology, Kharagpur, which is in West Bengal state. I am working on personalized ventilation and thermal comfort. So my interest is to make buildings more comfortable and sustainable and environmentally friendly.
Yeah, that's really interesting. And I know personalised ventilation is something that's talked about here quite a bit, isn't it? And really an up and coming subject. That's fascinating. Remind me to come back to that because we must talk about that. And yourself?
I'm Shruti. I'm Shruti Robert. I come from Kerala, which is located in the southern part of India. And basically, I'm a civil engineer. So I did my BTech in civil engineering from SEMS School of Engineering Technology, Karaguti, and it's affiliated in MG University, Kottayam. And after that, I did my master's, my MTech program in environmental engineering, again from SEMS itself, and it's affiliated to APJ Abdul Kalam University, Trivandrum. And after that, I had worked in 2 years for the research project, and it was in microplastics. It was in microplastics in the rivers. So it was in one of the urban stretch of a river, and also to the Vembanad Lake. It's one of the Ramsar sites. I worked there. So after that, I pursued my PhD. It is my PhD again. I'm doing it in SCMS. So it is affiliated again to APJ Abdul Kalam University itself. So the major thing was that I started with microplastics in river, and then it continued to another environment, air. So that is how I just started with my research project as such in air. So I deal with microplastics in air, and I'm focusing on indoor airborne microplastics.
That's really, I remember us talking beforehand. That was a subject I thought was really interesting that we've not really spoken about. You know, we're finding microplastics in the body. And, you know, the assumption has been through ingestion and through absorption, but it would appear that the air is now a real factor.
Yeah, we always talk about particulate matter, but I was very curious to know what is in that particulate matter in today, like in our modern lifestyle, especially when it comes to indoors. What is the composition of this particulate matter? We say it is dust, but according to the environments we go, the particulate matter composition can change. So in the residential environment, the composition of particulate matter will be different from that of an occupational building. And that exposure will also be varying because it's a very controlled environment, unlike outdoors where lot of dilution can happen. But in indoors, it's in our control. So and it is invisible to us. So if we don't identify it at an early stage, there are chances that there are a lot of health risks are there during their exposures.
That's really interesting. And that's another subject we definitely need to come back onto. So we'll hold there and let you introduce yourself.
I'm Pratibha Ramsal, an architect and also PhD scholar from Nepal. So my research mainly focuses on adaptive thermal comfort in office buildings. And basically wanted to have thermal comfort standard, which is basically focused to our own country. I think that's my area. So I'm also doing the visiting faculty member in the same university.
Yeah.
And so that's drive me to do the PhD.
Yeah, really
that's
interesting.
That's the reason, yeah.
So we've got an architect, an engineer. You're an engineer as well?
Yes.
Engineer as well. So 2 engineers and an architect. That's like oil and water, isn't it? Do you lot get on, architects and engineers? On camera, yes, definitely. Yeah. So let's go back to some of these subjects then, because they're all really fascinating and also intertwined, particularly when we're talking about the indoor environment. Personalised comfort and personalised air quality, this kind of concept of bringing our indoor environment down to, we talk about environments having to feed the human level, but we tend to talk about that at a zonal level or at a floor or a building level. This is a real step forward, isn't it? This kind of personalised comfort. What's your kind of thoughts on that sector at the moment? Because it's been talked about a long time. There's been research about it for a while, but we're not seeing it manifest out there yet as a real solution in other than very particular circumstances. I know we do see it. What's your kind of thoughts on this sector and what you're seeing through your research?
So the research on personalized ventilation systems was started way back in 1990s, as far as my understanding from the literature studies. So initially there were so many studies focused on controlled chamber atmosphere based experimental studies, and then they started collecting the data from the field studies, like how the humans are adapting to the personalized ventilation when the personalized cool air is supplied at the face level and the underfloor level, how the occupant is actually adapting to that cool air. And if there are any issues like sick building syndrome effects, or if there is any uncomfortable conditions created by underfloor air distribution systems, or if the airflow is delivered at the face level, the eye irritations kind of issues also prevail. So in order to overcome them, what systems can perform better? So they started exploring on different kind of personalized ventilation systems, and they started coupling with a secondary background ventilation systems. And most of these studies were focused on indoor atmosphere based studies. And there were some studies computationally explored, and they tried to evaluate how the airflow is interacting with the room air and how the temperature profile and if there are any issues in case of airborne transmission effects, and how to reduce those infection control, and how better the personalized ventilation system can improve the inhaled air quality of the subjects. So there was the research on different domains of these subjects, but unfortunately there were very few studies from the field. And but in the early 2000s, so there are some universities like DTU, Denmark Technological University. So they have conducted the experiments and they started implementing in a field. In fact, there were a few studies. I recently had an interaction with one of the scientists from the DTU. So I had a conversation why it was not practically implemented in the field. And he said that at that particular of time, people were not very interested to, have this kind of personalized ventilation systems in their office. And they are not ready to invest more money. And eventually there was one manufacturer which it was not able to, manufacture so many devices. So because there was no such demand at that particular time of period, so this research was not up to the level as it should be. But recently, after the COVID incident happened, so people were realizing the importance of, indoor air quality and how to avoid airborne transmission issues. So which personalized ventilation has the ability to provide, high amount of fresh air close to the breathing zone, so that there is a high scope that the infectious issues can be reduced. So now there is an increased interest, but still there is a need for field studies. So I think there are many institutes from the USA to European countries, and then there are some institutes in South Asia, and recently 1 or 2 studies from India. So different parts of the world are trying to explore through the comfort chamber studies, simulation studies, and field studies. And I'm sure very soon they try to come up with a standardization, the implementation guidelines, and etc. So once these things are standardized, I believe these systems will be manufactured, and very soon the industry is going to adapt these systems. This I strongly believe.
Yeah, let's hope. And it always strikes me, and perhaps thermal comfort might be the key to unlocking this, because there's that saying that you can't please all of the people all of the time. And as engineers, the first thing that anybody complains about is being too hot, too cold, in a draft, not in a draft, too stuffy. So you'd think, wouldn't you, as a pitch, as an idea for people working in a space, that being able to sit at a desk and set the parameter to your preference, whatever that is, because we're all so different in our preferences, particularly with thermal comfort, that it would be a winner. And the COVID pandemic has made a big difference with people understanding the protective nature of these kind of systems. But you're right, it's that who's first to move and create the products that are going to be sold into the spaces. I think it will be a real challenge. What's your research kind of focused on at the moment? What part of this are you looking at? Thermal comfort part?
Yeah. So my research mainly focuses on providing individual thermal comfort preferences, while also ensuring the high indoor air quality, while also focusing on the energy savings part. So this kind of work involves 3 stages of work, and we are also unfortunately not able to focus on the more field studies, but we are into providing personal level thermal comfort and high indoor air quality, while also focusing on the energy saving studies. And to this point, I'm also interested in coupling the personalized ventilation system with one of the low energy cooling system. So I am trying to do the simulation studies. If we couple with liquid desiccant type of system with a personalized air conditioning system, we can provide the air quality and comfort in a much better way, because the liquid desiccant based system has no compressor kind of components, so which is very much low energy cooling system. And the India is kind of a tropical climate where the required heat energy can be generated through the solar energy in India.
So for the layman, in as plain English as you can,
right?
What is a desiccant based system? What's happening there? It's not evaporative cooling. Is it evaporative cooling through a desiccant. How does that work? What is it?
So the liquid desiccant based system is basically it is a system that absorbs the moisture, because the system uses the liquid based desiccant solution like lithium chloride, magnesium chloride, then potassium formate. So these kind of solutions have a high affinity to the water. So when the moist air passes through this liquid desiccant solution, so it will absorb the moisture content from the air. So the liquid desiccant system basically does absorb the moisture from the air, and then it treats the moisture, and then supplies the hot air. And that hot air, if we can couple with the indirect evaporative cooling, and we can reduce the air temperature without much using the electricity.
So by taking the moisture out of the air, you're able to reduce the energy component in cooling it in the first place. Got you. That makes complete sense. That's one to follow up on, I think, is liquid desiccant cooling. And as a funny aside, I thought I heard, and it resonated for me, one of the potentials for personalised ventilation has been the move to working from home. Globally, we've seen a lot of very high-end organisations with very high-end staff working from their offices for large parts of the time. And an employer has a responsibility for the comfort and air quality of an employee, no matter where they work. So there's an interesting opportunity for personalised ventilation to be delivered in a working from home environment, because as an employer then, you're just having to manage the space where your employee works, not their entire home. And that's always the challenge from working from home is it my job to heat a person's whole house or cool a person's whole house? Or can I just cool the desk that he works or she works in for the day? It's a fascinating area. And talking of fascinating areas, my ears picked up when I spoke to you the first time, because I'd only just been having a conversation about particulate matter and the fact, and in fact, one of the podcasts that came out this week from me talks about a landmark report in England about air quality. And this understanding that the stuff that we breathe is moving across the tissues of the body and is multi-systemic, that there isn't a part of the human body, whether that's early onset dementia, Alzheimer's disease, cardiovascular disease, liver cancer, impacts on the endocrine system, you name it, the air that we're breathing is impacting our long-term health. But I haven't heard plastics as part of that conversation. And that makes complete sense. So you stumbled onto this. You were looking at plastics and microplastics in river and water environments.
Yeah.
What was the trigger for you for air quality? Was that a conversation that you had with somebody that said, have you thought about plastics in air? Or was this something that came up as a research thing? How did you move from water to air?
Yeah, so I started with the sediments in rivers. So I was focusing on near the landfill or the dump site. So obviously there were a lot of sediments, microplastics were there in the sediments. Later on, I moved on to the topsoil. So topsoil also have. So one by one, I investigated the environment. And interestingly, that time my research was just progressing and I was just entering to my PhD. So we have to set up this research proposal. So it was a very funny incident that I am quite an allergic person. So I'm having a dust allergy. So I just went to a shop where it was like a synthetic textiles shop. So it was not much of a big kind of shops. It was more like a wholesale shops. So when I just went there, I just told them to cut a particular kind of fabric. So it was like a go down kind of environment. And I just entered and they started to cut it and everyone else was sneezing there. So it was very interesting. It was very curious for me. Yes, obviously dust will be there, but a sudden thought was there, like only dust? That was a virtual question. So there will be particles, that synthetic particles, which also might enter through my respiratory system. So that was just a spark of my proposal. So later I just searched for my research, all this literature reviews, and I found that the study is really overlooked. Like there are a lot of studies in rivers and lakes and in even marine oceans. But when it comes to air, the studies are very less. So that is how I switched to the air environment. And unlike the other environments where at least we can control the movement or the dispersion of this pollutant, when it comes to air, we cannot actually control it. It is actually, the size is actually very less. Like when I did my field study for the sediments, maybe the size of microplastics would be actually microplastic, the size dimension is lesser than 5 mm. But the size might be like 1 mm or maybe let's say 500 micrometer to be the lowest size. But for the air, the minimum size starts from 200 micrometers and it goes down. And that was very much of a health risk when it comes to air because we cannot control that exposure. At least in water, we can just filter and we can just have that water. But when it comes to exposure from air, it is very much riskier. So that aspect of health and also that control, we cannot control that environment. So these factors was very curious for me.
Yeah, that's really interesting. So where are the boundaries of your work? As an engineer, are you looking at engineering controls and whether that risk is in the air and what are the effective mechanisms for protecting us as an engineer from that, like filtration or other mechanisms? Or are you starting to look at the evidence as well within your work of, can we tell if the presence of microplastics in the body is as a result of air quality? Where's your work start and stop? Is it at the measurement in the air phase and what we can do about it? Or are you looking at is it making its way into the body piece?
I started, like I was told before, I started from shops. I was very interested in doing for commercial shops. I'm not talking about the shops which is protected with lot of ventilation, etc. I'm talking about the shops like developing countries where the shops are not much ventilated. It might be like a go down. It's a wholesale factor where all these types, any kind of synthetic, I'm not talking about only plastic kinds of textiles, but any kind of plastic products that are stored in the indoor environment. So I selected a different kind of shops. So there was something like a toys shop, there was something decor items shop, and it was a Christmas season. So we do have lot of that kind of, even the Christmas tree that we find, it's definitely of plastic. So all this plastic, so I've selected some shops like that, and I just took the deposited dust from it, and I just investigated for the presence of microplastics just to know the characters, what we find there. So we find a wide range of sizes and a wide range of polymer types are found from there. So that is how I started my study. Later, now I'm in a phase where I wanted to know the pathways. Like when it comes to indoor airborne microplastics, when I talk about respirable microplastics, I want to know the pathways. Is it from just the indoor, or there will be a contribution from the outdoor, but from indoor itself, what is the pathways? What are the emission sources that can be leading to the emission of or the generation of this respirable microplastics?
Yeah. And you wonder at a microplastic level whether that accelerates off-gassing as well as plastics break down. I imagine exactly. You must be seeing associated risks with that not just the particle itself, but what that particle is doing to the environment. Really fascinating. So this sounds to me like all really early stage stuff. Have you found many other people in your field looking at this area yet? Are there many of you?
Definitely. I do connect to people who are working in, but most people are working in microplastics in water, but we do have a connection with microplastic in air, but they focus on the outdoor microplastics mainly. Yeah. There are just studies, very less studies. They are focusing on indoor microplastics, but I'm particularly focusing on respirable indoor microplastics.
Yeah.
So that is my current stage of PhD. So I'm very curious to know what are the sources and the emission pathways.
Well, it sounds like it's definitely one to keep an eye on because it sounds like a fascinating area of research. And I can imagine, because my head's already playing this out. You've got does it exist? Is it in the environment? How much of it is in the environment? Can we do something about it in those environments? And we can all imagine the kind of workplaces that create some fairly troubling environments in that respect. But I'm also then thinking there's an awful lot of medical tie-in here required as well, trying to understand pathways and mechanisms on the human body. Because I think we're only really just starting to understand that from a medical perspective, the impact of microplastics in our bodies. So it sounds like that you've got work for the next few decades ahead of you anyway, by the sounds of it.
Yes, my boundary actually I've not kept for the health part because I've consulted with scientists and NERI. So I've consulted with the scientist. So he told that we need a much of a health expertise to continue. So maybe for my postdoc, I'll pursue with that. But for currently, I'll only just focus on this emission pathways, just the sources and the emissions of this microplastic generations.
Really interesting. And I'm always fascinating, Prativa, architects in this space, because it's an interesting field, architecture, in that it's increasingly becoming a technical discipline. You know, the vision of an architect of old is a black polo net wearing artist, you know, scribbling beautiful buildings, right? We all know that kind of trope. But increasingly now you're getting really into the depths of building science and physics, but you come at it it's a different viewpoint, isn't it? I imagine it, and particularly I imagine from the adaptive comfort perspective, trying to understand how you make spaces work for people.
Yeah, exactly.
Yeah, really fascinating area. How do you describe what you do to people? So as an architect looking at adaptive comfort, particularly in workplaces, what are the kind of outcomes that you're looking to achieve through your work and your research and what you're doing?
As you just mentioned, that adaptive thermal comfort is more related to what people are doing to adapt their indoor environment, right? So my focus is basically towards the adaptation, how they are behaving in their environment to be comfortable inside the office building, right? So there are basically 3 types of adaptation. There is behavior, psychological, physiological, right? So I'm looking after only the behavior part, how they are behaving, that might be the clothing level, that I'm wearing this kind of clothes, and in summer people are wear only t-shirt like you are wearing, and winter people use jacket things, right? So I'm looking after that thing, behavior, that is one behavior. Another behavior might be people are opening the window. That is also behavior parts, right?
Yeah, so physically interacting with the space.
Interacting with the spaces, being cozy while sitting, those kind of thing. One part is that, and another thing is basically in the if you see in the worldwide, there are so many standard about the thermal comfort, adaptive thermal comfort model, right? If you see there is ASTRAE standard, the global standard is ASTRAE standard, SANI standard, it is from Europe, and IMAC there is from India. So what I believe is adaptive thermal comfort is based upon climate and context, and also culture, right? So it is the adaptation behavior is dependent upon, it is influenced by the climate, culture. So I wanted to see what is happening in our context, since there is no thermal comfort standards in our country. So I wanted to look upon that part. So how people are behaving in their indoor environment to be comfortable, and also what will be the model. In simple terms, they are giving in the model is if the outdoor temperature is increasing, our comfort temperature inside the building will also increase. That kind of model has been developed worldwide. So I wanted to say whether in our countries, what will be the model, and also looking after that behavior.
Yeah,
part.
That's really interesting. And from the architect's perspective, that's feeding into how you then create the spaces, the physical spaces that work for people in that regard. Can you provide environments that give people the agency to interact?
Exactly.
You know, that a lot of the challenges, particularly with thermal comfort, is the feeling that you can't control the space you're in. Exactly. You know, or that you haven't got areas where people that are more comfortable can be and people that are cooler can be somewhere else. And I always love the image of there's a great picture in Paris taken at exactly the same temperature, one going into winter and one going out of winter. And going into winter, everybody's wearing coats.
Exactly.
Because they feel
Yeah.
warm from the summer, and this feels like a really cool day. And then in exactly the same weather conditions, 6 months later, everybody sat there in short sleeve shirts because they've adapted to a different temperature over time. Yeah, it's a fascinating space that when you add the human ingredient to it, it's really interesting. I think the next really interesting part to come on to is kind of a two-parter really, is the kind of how you got here and the where you think this is going piece. Because I always think they're really fascinating to understand. Because you're coming from a younger generation, that's quite a condensed period of time. So maybe if I start with you, like, how did you find, what's been your kind of journey to doing the work you've done? Because you've done quite a lot. You know, you've been both in academia, then out in industry, then back into research again. Like, how did you find yourself at the beginning of that journey? What was the thing that kind of triggered, or is it just, you've just kind of found yourself falling into air quality?
When I have completed my bachelor's degree, then I immediately started working in industry. So where we are given certain tasks to do the work in office buildings. So basically what we are doing is some senior engineer will be designing the buildings in terms of HVAC systems or building services systems. And there will be one senior architect who will be coordinating with the services drawings and architectural drawings. So for every project, there is a similar pattern. And I believe that with every project, there are different design challenges and different ways to, showcase the talent and have innovative approaches. But what I have personally experienced that everybody is going through the same pattern of, designing, doing some calculations, coming up with a certain design criteria and then go with the architectural coordinations, and then they just keep on implementing it. So I kind of felt that entire process is very boring, and we are not actually putting our innovative approaches or whatever our ideas, whatever we think the solutions can be implemented in a different way. So we were not actually being, utilize those kind of skills there. So I thought I would try to pursue my, specialization studies on sustainability. And then I went on to do my master's in building science and technology, where I have studied the passive kind of cooling technologies, the natural ways to, cool the buildings and reduce the energy consumption of a building. So I have learned a basic fundamental knowledge on these things during the master's time. And then when I completed master's, I started working as a research assistant in one of the Indo-US joint project. So I'd like to thank my boss. So he has given me the good opportunity at the early stage of my career. So where I started overlooking the experimental studies, and I tried to kind of deal with the data analysis and try to look into the different variables, the variables that are playing a major role in providing comfort, and how the energy consumption can be reduced, and how the air velocities are playing a role in, increasing slightly more higher temperatures. So this is where I have got my spark of, getting into this side of research. So basically I have got my interest in thermal comfort and air quality research idea began from that point. And then after I have joined as a visiting faculty in Hyderabad for one semester. Then I had started teaching 1 or 2 subjects where I felt myself challenged. So we need to prepare, and then we have to teach to the students, where students will come up with different kind of questions which I have not experienced before. So I think this is a little challenging to me. And then I started looking into the literature papers. I kind of started developing a research proposal at that point of time. And then I started applying. Then I joined in Indian Institute of Technology, Kharagpur. So where I was continuously developing the refined proposal. And then when I started looking into the literature papers, then I realized how important it is to, do more further research in the area of thermal comfort and indoor air quality. And there were so many incidents, like people were uncomfortable. Like if we take an example in office buildings, people from the different climatic background and people from the different lifestyle come and work in a same office environment. So it is often like difficult to provide each person preferred comfort conditions. Then I started like diversing my literature study, and then I found the research on a kind of particular domain called personalized environmental control systems is been going on from more than 3 decades. And recently, kind of after the COVID incident, many people were started taking up these areas into their research career. And I feel there is a more need, and there is still more scope to explore in this area, while also to if we want to provide subjects individual comfort conditions, it is necessary to explore a kind of technologies to provide those conditions.
Do you know what strikes me about your journey is it's that classic engineer turned researcher journey that's doesn't like the look of the normal, and just keeps going deeper and deeper into the there's got to be a better way, there's got to be a better way, there's got to be a better way, you know, and the more you specialize,
right.
So you've gone all the way from kind of mass production buildings and engineering to sustainable green buildings to thermal comfort's really important, personalized, you know, you get down and down, down and down. Yeah. That's really fascinating. And of course, teaching is another skill in and of itself. And, you know, nothing makes you know your subject better than having to teach others that subject. Yeah, no, really interesting. What about yourself? Like, how did you find yourself? Well, you said you started looking at plastics and sedimentary in waters and rivers and things. Because when we were talking earlier, we talked about a little bit about your transition from plastics in water to air quality. But I'm interested in how you kind of got there in the first place. What kind of brought you into that kind of environment engineering?
Okay. Firstly, I started in with rivers. So there are 3 sectors that I did in with rivers. It was water, it was sediments, and it was topsoil. And along with the rivers, I also have examined for fishes. So in fishes also, I used to find this microplastics, but in a very, very lesser size and also very lesser quantity. So that was another thought for me. If it can be a factor in fishes, then why not in humans? So that pathway was by ingestion. Like when we eat fish, definitely there was another controversial stuff was that we remove all those parts and gut part from the fishes and only then we eat it. But we also have found the microplastics from the fish tissues that we eat it. And also the dried fish, or we have a custom or the delicacy of having the dried prawns, etc. So such fishes, or even oyster, these organisms are very resistant that they can accumulate these kind of microplastics in them. That is the first thing. Why not in humans when inhalation also?
Isn't that always the way though? Isn't it amazing how often animals are sentient to humans? You know, we talk about the canary in the coal mine, don't we, as the trope for a bird. And it's true, birds will react to gases in coal mines faster than humans. But we see that across the environment, don't we? Cats, dogs, fish, our food supply chain, all of these things seem like early warning signs for, hang on a minute, this is in the fish. This is in the fish. Tell me why this isn't a good story that it's in us as well. Yeah.
So that was the first thing. So the second thing was when it comes to humans, what happened is that there only the pathway was ingestion from the fishes. Now from here, from like when you consider the indoor airborne microplastics, I'm talking about, let's say about indoor microplastics. So ingestion is not only one of the pathways, inhalation is also there. So ingestion in terms of the personal products that we use, that might cause ingestion. But for the inhalation part, again, the exposure is uncontrolled. And the main thing is that there's a single effect and a cumulative effect. Single effect is something which is only related to microplastics, that is, we inhale microplastics. Cumulative effect is something, the microplastic and any other pollutant which is present in the environment, indoor environment, it can form an interaction and it can enter the respiratory system. Because this microplastics because it's very tiny, it's having a very high surface area. So be it bacteria or any kind. There are studies where the indoor environment is polluted with microplastics and the interaction with bacterial infection is also there. So the chances that the risk factor will increase in that case. The cumulative effect will cause more effect because even if it's in dust, the residence time of the dust or whatever pollutant, it will increase. If it's bacteria, if it is a respirable airborne microplastics, like PM 2.5, it's part of it, we inhale it. So that factor was very important for me. So always when I connect with it, I always connect this microplastics not just as an indoor air quality terms, but more of like indoor air quality and health terms. I try to link with that so that I get a better definition in terms of this indoor airborne microplastics.
Yeah. So what's really interesting about your journey is this working in one environmental engineering field and just seeing this direct potential correlation to, well, tell me why this isn't a good story. And all of a sudden, I guess at some point you're looking into a void and going, well, where's the research? Like, this just seems obvious to me. So now you're looking at a very new space, I guess. There can't be many people globally researching and looking into this. So it's going to be a fascinating area to see how that progresses. What about yourself? How did you obviously went through the classical architecture courses.
So it was like, since I'm an architect, so I always admired the vernacular architecture. So if you say in Nepal, we are having like vast altitude difference. It is like ranging from 60 meter to the highest top of the world, like Mount Everest, right? It is 8,800, so 48 meter. So we are having lots of different vernacular architecture, building physics we can see over there in the traditional building. But now what is happening is everywhere same type of buildings is constructing in a lowland, also in highland, right? So what is impacting is like energy consumption is being higher as back import is going higher these days, right? So that trigged my mind. So we need some standard or like a guideline or some kind of course to do better in that condition. So since I'm an architect, what I thought is like having a thermal comfort standards might affect that kind of thing. So if we have such kind of standards in our country, at least we don't have to rely on much energy consumption kind of thing and ASBAC kind of thing for the thermal comfort inside the building. Since in a literature, I have read that even 1% of energy, even 1 degree of temperature, if you can lower inside the building, it will save about almost 10% of energy, right? So my target is that to have a standard in my country. What can I do from my side? It was started from that point, yeah.
It's really interesting that, isn't it? And it's this, we've seen this so many times with architecture over the years, is this, that the buildings have had a typology because they've adapted over long periods of time to the climate conditions and the skills and the materials in a particular area. And the pace of change was generational. So you didn't survive very long as a builder in your local environment if you weren't adapting the buildings to work. We have a classic case where I live where we have these old cottages on the west coast of Ireland that are incredibly airtight. But you didn't build cottages on a windy coast in Ireland if you didn't know how to keep the drafts out. So we've done that for years. And then in the last few decades with modern materials, we've felt that we've been able to completely disassociate ourselves with the environment that we're in. And I'm guessing in your field where you're talking about adaptive comfort, the human-centered approaches, you can't just remove yourself from the environment you're in. You've got to, it's got to be reflective of where it's being built.
Exactly.
That must be fascinating in Nepal, that just the sheer differences in climate conditions over short period, over short distances.
Yes,
yeah.
exactly.
It must read like a book, I guess, when you're looking at the archetypes of buildings. You must like from every 25 kilometers, there's almost a completely different type of architecture.
Exactly.
Yeah.
If you travel from the north to south, you can see the different typology of building. But it's like for a vernacular architecture, it was. But now it is gone because people are building the modern building everywhere. They don't know what is the pros and cons, what will happen, the thermal comfort, what will be. They don't know anything about it. So they are towards the maintenance-free construction. So they are building same type. So my concern is at least we should have thermal comfort standard. That might be the starting point.
Yeah.
At least that is something.
Really interesting. And I knew we were going to run out of time because it's three fascinating subjects we could have a podcast on, even on their own. But there's a couple of things I wanted to touch on before we left. One of them, which I think is an interesting question, and this is if I was advising my little brother or sister who's just thinking about going to university, what advice would you give? What areas or directions would you go in? Because you've all done generalist degrees to get the basics, the engineering, the environmental engineering, the architecture, and you've all found yourself specializing. So someone that's in school starting to think about third level university type education, what would your advice to them be? Where would you be saying, look, this is really exciting, I'd look down here?
I would like to mention this in two different perspectives.
Yeah.
So the one thing is that, so I would like to definitely take upon this aspect of climate change scenario. India is a vast country with different climate zones where the air conditioning system usage is around 3%, which is around 4 years back. This, according to a study, so this the usage of air conditioning systems is going to be 5 times more than what it is in the 2021 year. So more and more people are going to be using the air conditioning system, and also in the events of extreme weather climates. So it is the usage of air conditioning system is going to be the must for lower income group to the high income group. So there is a more scope for inventing more new technologies in air conditioning systems. So right now we have been using the refrigerants which are harmful, and of course there are natural refrigerants are also being used, but the efficiency of the air conditioning system plays a major role. So the invention of a new kind of or new generation of air conditioning technologies holds a great potential. And we are always talking about thermal comfort, personalized ventilation, individualized comfort systems, etc. But the part of air conditioning system equally plays the role. So if I have to give some advice or suggestions to the kind of people you suggested, so I would like to mention, I would like to suggest the scope that we have in the air conditioning domain. So there is still more scope, and recently there was global competition held in India called Global Cooling Prize competition, which supported new generation air conditioning technologies people were inventing, and people are still trying to improve the efficiency of the air conditioning system. And I think this will go on for many more years until we achieve the carbon neutral so environment.
Plenty of scope in kind of cooling of buildings and dealing with climate change. What about yourself? What would you recommend, having kind of fallen into where you have? What would you suggest to a little brother or sister coming up who's going, what should I do? What would you recommend?
Okay, so I have actually two perspectives. One, regarding research, I would say even in microplastics or air quality, there is much more to explore. So I can just talk about microplastics and airborne microplastics. So you have a lot of research gaps in this particular field because it's just an emerging pollutant, and it will be a major pollutant maybe in a decade. So there are a lot of research gaps, starting with the identification of the pollutant. There is no standards. There is no unit to standardize it. So there are a lot of research gaps. So you can explore a wide range of areas in this particular specialized field itself. And the second thing is perspective is like to the younger generation or the people is that the materials that we select in our indoor spaces do matter the air we breathe.
Material sciences is a really key area for the future, isn't it? For sure.
So like that actually it's a controversial topic. I understand that. But now Kumar was talking about ventilation and she was talking about thermal comfort. This both are linked to my topic as well, because the materials that we choose, like when the temperature is varying, even if it's a lower temperature or a higher temperature, we call it as weathering. So with the weathering just means that the breakage of this plastic materials into tiny plastics, that the intensity will be very much high. And also if any kind of ventilation is not proper, as I mentioned in beginning, especially when it comes for the low income or the developing countries, where they do not have any botheration about the ventilation, especially in the occupational areas. Because I have personally, during my field study, have seen that the people who are dealing in the plastic recycling industries or any other industries, they do not have a personal equipment to protect them.
Yeah.
So I have investigated in manufacturing shops where they were cutting these plastic pieces. So that small pieces were lying down and they were just using a broom, they'll just clean it off.
Yeah.
But they're not aware, because that they don't understand, they're not aware about that hazardous thing that they are doing about it.
So it sounds like there's some really big areas for research in that space, but also some real potential for practical implementations that would make meaningful differences.
In research and when it comes to practical ways, that awareness is very much important.
Really interesting. What about yourself? What would you say to someone looking into this space?
So I agree with Shruti, as she mentioned that material really matters when we are residing inside the building, right? So since I'm an architect, I'm more focused into the building kind of thing. So when you are thinking about making a building, we should consider climate, context, and culture, right? So that is particularly related with the indoor environment quality, to maintain the indoor environment quality. As I mentioned earlier about the vernacular architecture, what we see is they are breathable. So that we don't see like we were measuring the CO2 here, it was 500 something. You can see that thing in the traditional building. But what we do now is we don't care about the outdoor air. It is already polluted. We say that thing and we already close our windows and something like that. So we have to be very specific, or we should have awareness about that. What will impact that thing? If we are closing the window, what will be the inside? We have to consider that thing. So it's like in our country, there are not much research regarding thermal comfort. There are few, but there are just few. So what I suggest is there are lots of things that should be should be done from the field, right? And they are not aware of the indoor environment quality. What is she's talking about the microplastic thing. We are talking about the thermal comfort. There are so many CO2 concentration levels. So that is basic awareness thing should be from the school level or some kind of thing, right? So basically, I think that since we spend 90% of time indoor climate, school or in workplace or in home, so that is
there's a real social science element to it as well, isn't there? There's the behaviour, the agency, the how people react and work in spaces. None of us use ventilation systems and air conditioning systems the way they should be used. There's so much work that could be done in building spaces that people can actually use well. Pratitha, Shruti and Kumar, it's been an absolute pleasure talking to you this afternoon. Thanks for taking the time to talk to me. We've run out of time, unfortunately, but I could talk to you for hours about all three subjects. I think they're absolutely fascinating. I'll let you get back to your conference. It's been a pleasure to meet you in person, having met you all online. Thanks a million.
It's really a pleasure sitting with you and having this conversation. I've been, following some of your videos on LinkedIn and the YouTube. And I think this gives different perspectives on, the different domains of air quality, the healthy environment. And I think your podcast sessions, have given new perspectives on different domains of research areas. And we would be looking forward to your upcoming, sessions also.
And I think things like the Healthy Buildings Conference here, it really enables us all to connect, because although there are regional perspectives, we're all fighting the same battles often when it comes to air quality and health. All three of you, thanks a million. Appreciate your time.
Thank you very much.
Thank you so much.
Coming right up, we have a conversation with the industry, and a really interesting mix, I think. Again, in order of appearance, a conversation with Tavinder Singh, Director of Asperg Ventilation, PVT, Vitali Matunin, Co-founder and CEO of AirVoice, and Deepak Nanaware, Head of Engineering and Marketing in the Middle East and India for American Air Filters. Well, I appreciate enormously you taking time out of the conference to come and see me, because I know, particularly from industry, it's a fantastic opportunity to meet both customers, but also academia and what's happening ahead of things in our industry. It's an incredibly packed conference from an agenda and a topic perspective. So I enormously appreciate you taking time out of your busy day to come and talk to me. I know I've had to come and grab you all and bring you up here. So I appreciate it enormously. Because there's three of you, and it's quite unusual for a podcast for us to have three people from three different companies, I think it's worthwhile us introducing ourselves to each other. So particularly people listening through audio know who's who. So perhaps if we start with yourself and just explain who you are and what your company does here.
I'm Tarinder Pal Singh, Director of Asperg Ventilations Private Limited, India. And from last 8 years, we have introducing our product lineup in ventilations with the ERVs, HRVs, fans, pressure fans, and so many accessories that we try to fill the gap for our HVAC contractors and consultants, so they are not getting involved into ventilation solutions, and people are very less likely to give a healthy indoor air quality rather than air conditioning. So they are more into giving comfort than to air quality. So we need to introduce ourselves. From last 8 years, we're doing good now in India, and we have 2-3 partners outside India also, in North Africa, Nepal, and Bhutan also. This way we are trying to mature the market to know about what is in the air and what air we need to breathe in. There are so many other things that we are doing so.
Very interesting. So how about yourself?
Hello everyone, my name is Vitali. I'm the CEO and co-founder of AirVoice. We build air value management system. So we believe that air has a lot of potential and had a great value, which remains untapped. There's a huge difference between what people want to breathe and what they actually systems perform and give people the air to breathe. Whether it's a building environment or industrial facility or a city scale project, we have the simple process of monitoring, analysis, and implementing of solutions. And last but not least, the feedback loop. After implementing solution, you need to go back to monitor, again analyze the effectiveness, and again adjust the implementation. Even if this process sounds simple on the paper, it's not that easy in reality. And we see our role and our value to the market to handhold the clients on this bumpy ride to improve air quality. And we envision in the future that it will be possible to address and streamline all of these processes in one single platform, which we call Air Value Management Platform, which actually will get people to the end to unlock this huge potential of air and to get not just the air, but also the whole value out of it.
Yeah, really interesting, really interesting. And yourself?
I am Deepak Nanaware, representing AF International, and I am heading engineering and marketing for India and Middle East. AF is a pioneer into the air filtration industry, standing there for last 104 years. It's a part of a Daikin Group company, and we represent majorly into commercial sector, industrial, as well as into the power, oil and gas. In India, we are dominant into the pharmaceutical clean rooms solutions, as well as into the healthcare. In Middle East, again, we are doing major into oil and gas, into the power sector. So we are basically not just a manufacturer of the filters, but we deliver the air filtration solutions across the world.
Yeah. I'll have you back to the podcast in just a minute. I just wanted to briefly tell you about Eurovent Certified Performance from Eurovent Certification, a partner of the podcast. We all know HVAC systems play a vital role in improving indoor air quality. However, there is a risk that some products may not live up to expectations. Even the best installed and maintained HVAC equipment can underperform if data used to specify products and design systems is incorrect. Consequences can include poor indoor air quality, increased energy consumption, increased maintenance, system failure, and non-compliance with regulations, and that's bad for everyone. However, there is a way to ensure products perform as advertised and deliver good sustainable indoor environments. Selecting products holding Eurovent certified performance ensures that the manufacturer data has been independently and impartially verified. Eurovent certification's stringent certification process not only guarantees product performance, but energy efficiency too. I met some of the Eurovent certification team back in January at the Indoor Air Quality Matters conference and was seriously impressed with what they're trying to do. Their core aim is to create transparency in the industry by making certified data freely available. This means you can directly compare the performance of products to make informed decisions. Their certified product directory holds vital information on everything from air handling units to air filters. So don't take a chance on unverified products. Trust in proven performance. Details, as always, in the show notes at airqualitymatters.net and at Eurovent Certification. That's www.eurovent-certification.com. Now, back to the podcast.
And I think what a really fantastic mix of ventilation and data and filtration, answering, three of the critical pillars in good outcomes for air quality in the built environment generally. So I think it's a brilliant panel. What I thought would be really interesting to understand, because this is a global audience, is some perspective on the region more broadly. And I think an interesting way of asking that question is, what are we not talking about that we should be in this region? Where are the gaps as you see it?
When I studied all these things, when our basics of air conditioning and ventilations, when we start calculating AC tonnage, when we start calculating ventilation requirements, we only talk about square feet areas, number of people, volume of the room size. But we are not taking a name of air. Actually, we are, in the background, we are doing air conditioning to cool down the air, not the area square feet. And in ventilation, we definitely have to change the air, but we are not talking about the air. And so that's why the name air has to be mentioned when you are calculating and when you are considering any tonnage or air changes. So it's all about air. When we are into a HVAC industry, we must know about the air quality and air comforts. Comfort will come from the air conditioning segments, and quality come from the ventilation segments. And with quality, we have to know about the PM 2.5 levels, CO2 levels, VOC levels. These are some concerns which are not into the topic when we are into this industry. There's very much lack of this thing. When we name air, then we will come to the quality and comfort.
Yeah. And I see the other two nodding here. I mean, this is a
this is the classic conundrum, isn't it, with air, is this the ventilation from the perspective of checking a box, have I got, is it right for the room size? Is it right for the number of people? And not actually thinking about outcomes. It's about, have I done what I need to do on a check sheet? And the balance between thermal comfort and air quality, and particularly in regions where climates are more extreme, whether it's here where there's a need for cooling, or in colder climates where there's a need for heating, we find that friction there all the time, and that visibility of air is so important.
When we talk about thermal comfort means the air we are feeling at our skin, right? We talk about thermal comfort, but we are not talking about the air, but which feels you comfort.
Yeah, it's amazing. And I imagine that's something that you relate to very heavily with the work that you do, is that trying to make the invisible visible and trying to give people that picture of what air quality looks like.
Definitely. Like, I've spent in India more than 3 years now, and for hundreds of meetings with building owners, with company owners, top management team, engineering team, building management systems, and etc. We've seen a lot rejections against air quality projects with the saying that we don't have money for this. But in reality, it's not the money which talks here. It's lack of understanding what's need to be done and how exactly it's going to be done, and lack of assurance that this solution will actually work. So part of I think the answer to your question is that some unspoken rule here that nobody wants to get it out, that a lot of people doesn't know the basic stuff of air quality. What is a carbon dioxide? What is particulate matter?
People don't want bad news.
Yeah. Yes.
Actually, the point, sorry, I want to add that we are not talking about our lives. We are talking about the business, money, buildings, all these things, all this stuff. We want to create our image online at Instagram, but we are not serious about our life requirements. The air is the basic. Water is the basic. About water, we know which water is good and which water is bad. We have to be bottled water everywhere. We know about the water. But what about the air? We need at least 550 liters per day. And the water we need only 3 liters per day. But we are not talking about the air.
Yeah. And I think another perception how we can address this question is that there are some visible industries and there are some like invisible industries. So, for example, not a lot of people knows what type of concrete their house had been made of, and they don't care about it. They just care about the end of the result, that the house is strong and they can safely live there. But the air has to go from the dark to the light back. So it has to become a visible industry, and we believe that one of the solutions to the problem, what we're discussing here, is that if we make it visible and if it make this data accessible to every layer, not only to engineers to understand, these will create fundamental changes, because whatever is visible for end users start demanding the good quality of it. And that's also kind of something that people not usually spoke about in India as well, because the air, if you make it visible without improvements here, a lot of people will get afraid of it. Yeah. So that's why it's important to make it in the most careful manner.
Yeah. And I think assumption's very dangerous as well. And I imagine you can relate to this enormously, Deepak, is that taking industries like pharmaceutical or larger oil and gas industries, the hotel industries, the big shiny buildings in the Middle East industries, the assumption is that they automatically come with good outcomes. And that's just simply not the case, is it? That both in the design of them unless they've engaged with professionals like yourself. Fundamental mistakes can be made, but also in the operation of those buildings over time, we see a deterioration in things like filters and the outcomes that we just expect, because the assumption is pharmaceutical is a clinical, precise industry, and automatically air quality is going to be great, right?
Yes. So you mentioned that what is not talked about is that admission by the people that they don't know about the topic. If you ask me, in India, I can say you can count on the fingers the people know about the IEQ or the air filtration in real-time application. Because I have met so many people, and sometimes I have to control my laugh or my anger by the understanding of the subject. See, I am not an expert. I have a total 2 decades of experience. Out of that, 1.5 is into HVAC. So I know the problem, I know the industry. I have been into filters with AF for 6 years. But always people asking what is not possible. Like in India, people try to wash the filters, the pre and fine filters, which if not the practice followed anywhere globally. Okay, then what is the right rating or the efficiency of the filter I should be using? It should not be that you should go with a pre and fine filter or the new guidelines PM10 and PM2.5. You need to understand what's your application, what is the occupant requirement, what is the outdoor conditions. So when you have a building next to a polluted water body or a garbage dump area, you cannot just rely on the particle filters. You need a gas phase filter to handle this. And then this awareness is missing, I will say, from the academic level till the professionals who are designing and executing the building. So as you mentioned, the design and operation, in both the sides, this awareness is not there. So in India, if you see, the designing of the building is normally handled by the MEP consultants along with the architects. Now, that's another topic. I will come to that also. So most of these consultants who are focused on, again, as he mentioned, on the HVAC, so heating, ventilation and air conditioning. In air conditioning, they just see the temperature, because that's immediately affects the human comfort, and the people complain, I am feeling hot or too cold. Nobody bothers about humidity, bothers about the PM count, unless and until it's a very strong smell or odor coming up. Otherwise, they will not complain, or then they push the air fresheners to convert one molecule to another molecules. So that is there. Secondary, again, in the operation side, people don't know. He has been doing this for years, so he will take any filter and he'll try to wash it, whether it's a disposable or cleanable. He doesn't know that. He simply follow what he has learned through his experience. So I see that bigger gap into the awareness and the education from the college level. We try that educating college students about this topic. And the second topic I was mentioning about the fight between the architects and the MEP guys, that always the aesthetics prevail over the functional requirements. I don't want the diffuser here. I don't want the grill here. I will not give you the space for the outdoor air system. I will not give you the space for the fan and everything. So somewhere, as a designer, as a manufacturer, we have to compromise, we have to adjust and accommodate this request.
Yeah. And it's not a lack of resources in India in the sense that there's an awful lot of really talented engineers and architects in India. You know, that's clear when you talk to people here. So it's not a lack of talent. So there's a gap there, isn't there, in that knowledge of, sometimes you wonder if it's the problems we create for ourselves are in the words that we use. And you're right, HVAC, people, you wonder if it really triggers for them what the ventilation part of HVAC really is for. And we finish it off with air conditioning. Perhaps we should have been calling it something different all along, heating, air quality and comfort outcomes or something, It's a challenge. How do we address that education and knowledge gap, do you think, in India? What's the route there? Obviously through colleges and universities, but you've also got to get the buyers to understand, haven't you? How do we start to bridge that gap in India where people take air quality seriously, do you think?
In a urban level, like when a good architect building a good house or a good office building or good hospital or clinic, they are only concentrated toward the aesthetics of indoor and outdoors, because they don't know about the air, what is in the air, and why it's important to see what in the air and how to clean that, or which air is good for us, good for the occupant, for they are building that building. They have a lack of knowledge actually. Just is right. It should be start from the architectural colleges. There should be a subject of air, because when they are building a sealed and like airtight buildings for more energy efficiency for air conditioning, they must know what air quality should be there in that building, how to maintain that air quality. And first of all, they have to measure it, and they must be known about which parameter we have to match, or which parameter we have to achieve that to give good quality of air to the occupants. This is the main concern.
Do you think some of the answer, I mean, we saw this in China with the under the dome period in China a decade ago, where ambient air quality became such a problem that it reached the public consciousness. And the reality is even the majority of our exposure to outdoor air is going to occur indoors in the built environment, because we spend so much time in there. Do you think there's some analogy to that here in India? Do you get a sense that the general population, that the non-engineers and architects, the business owners, the public, have an increasing awareness of ambient air pollution? And do you think perhaps that could be one of the keys to unlocking better knowledge?
Yeah, I believe there's like two ways, and I don't think following only one way would be beneficial. We have to follow both ways simultaneously. So one way is like make it natural, and another way is to force people to educate themselves. So you can create a standard or like demand for certification or level of education of anyone who touches HVAC system in the building, or anybody who runs building management systems. You can like start demanding the certain level of certification or educational platform, and the market will create this kind of education for the people, and they will eventually be extremely educated and they will take right decisions. But on the other side, this is only like forced way. But on the other side, you can make this topic or this profession or this idea to have pristine air quality a little bit more fancy, a little bit more glamorous. Like people like to stay in a 5-star hotel. So it could became the same as a shield, which you can put on the door, and people get much more excited about to stay in a hotel with a perfect air quality. And it can go beyond the hotels. It can go everywhere in all type of buildings, and it should become fancy and popular to breathe clean air, and that eventually will generate a lot of demand for it. And where the demand, there will be supply. So there will be a lot of demand for high quality engineers who can deliver good results, and that will sparkle up more and more people willingly pursue this type of higher level of education in this topic.
Yeah. And also we need to lean on the opportunities that are presented to us when we have them. And one of them in the built environment is energy and the need to reduce costs and cooling. And one of the interesting things about filters particularly now is this new view of equivalent air change rates, and the fact that we can reduce outdoor air by filtering and protecting the built environment with proper ventilation and filtration. So I like that idea of the barrier, as you say it, that we have barriers from the outside into our buildings for the air that we need to bring in, but we also consider how we manage the air when it's in the space, and we lean into the energy saving potential of ventilation, because it's often seen as an energy problem not an energy solution, isn't it? And I guess that's a conversation, particularly with gas phase filtration, that you have regularly, is that ability for people to think about a space in a fundamentally different way.
This has always been a challenge, and I have been talking on this with the designers, especially the consultants, because people try to go for the certifications like green building or well and all, and more or less the green building focuses more on the energy consumptions, how efficient is your building, and people are talking about net zero carbon neutrality in the buildings. But then my question is to them is that what's the right energy consumption, and at what cost you should reduce the energy consumption. As he was mentioning, that people want to save more and more energy, and then they want to stop taking the outside air. They don't want to add multiple stages of the filtrations to clean the air. But then that is at the cost of the human beings or the occupants inside the building. That never calculated. I don't see any ratings on that part where it is helping you to achieve a higher rating into in the green building or the well certification, because they just, okay, we are given the guidelines, you should use MOW 13, you should use gas-based filters if these conditions are there. But then most of the people don't do the analysis of the air quality before starting the building, so that you can plan from the construction stage itself. So again, the awareness, I will say, to be started from the schools, in colleges, as well as the professional bodies. Because why I say school? Because I see in a campaign in a green building only, where they conducted an competition with the school kids only, and then they got too aware of the subject and they started pushing their parents at their home. We should do this, we should save water, we should save energy. And that's what we should start with the school, maybe a chapter into environmental science at the higher grade of school, which can reach to the multi-level people across the country.
Yeah.
And that will be bigger approach instead of going for an institution. That is, we have to do. And that will happen for the future one. But these people will help us to reach to the wider audience.
And we've seen that globally, that ability to light up the imagination of the young people and start to create a framing and a language that they start to understand and they bring home to their parents, and you start to create awareness. It's really fascinating. We'll run out of time, but I did really want to talk to you all about what your hopes are for this region and this sector. What do we hope will happen in, let's say, the next half a decade or so? If things start to improve the way you would like, what are the kind of stepping stones or roadmap that you'd like to see start to fall into place?
Yes, definitely. From if I see from last 8 years from my journey, when I talk to people about the mechanical ventilation and heat recovery, nobody would interested to listen to me. That is important. But now we are on a very
post-COVID thing.
Very post-COVID thing. Now we are doing very good in our region and pan-India. People are getting aware about quality of air and sealed buildings. Yes, many architects are now involving in keeping this kind of solutions at every home and every office. Yes, the journey is so long. It's if I say it's almost 5% to 10% persons who are giving this kind of solutions at every building they are making. But still 90% are still not doing that. So this is our motto, to aware all people and the professionals majorly must keep these solutions to keep our next generation healthy indoors, because we are spending 90% of the time indoors. So what air we are breathing is very important to every part of life. Every life is important. Yeah. As per surveys, people are aware that these things are very important for our life. There are so many diseases which are coming from the air and we are breathing in. Still, because when we drink bad water, we definitely know about that in a day. We are having bad water. But when you are breathing a bad air, it will take 1 year, 2 year, 3 years to know that for human life. So it's tough. It's really challenging for us as a profession and to educate people to do invest in these things, because this everything cost money at the end of the time. They have to invest it to get a better air quality.
So at a very basic level, just the recognition that this is important, the basic building blocks over the next 5 years, that it's a line item of consideration in every building is ventilation needs to be discussed. Yeah, what about yourself?
There is something what we believe should happen, and there is something what we hope. So something what we believe that it's not going away. It will not fade out. People will not forget about air quality problem in India for a long period of time. It will never. You cannot close an eye to everybody to this problem. So the problem will remain there. The question is how we are going to be solving this problem. And what we hope to is that the topic of air quality will become as normal as a topic of air conditioning or as normal as like water quality. Some of the fantasies of some of the people are that air quality monitor can become as normal as a thermostat. In each and every office, each and every room, there is a temperature sensor, relative humidity sensor, and people get used to it very quickly. So it is possible to get people get used to see air quality on a daily basis and control it just in each and every building without a single question, what is this? People will be capable of doing this. The only question is, do we have that technologies? Do they cost that much that everybody can afford it? And do we have this level of education and level of new reality where the air quality will become fancy, and later on, after becoming fancy, will become like a new norm, which nobody can live without. So that's our hope and that's our vision combined together.
Brilliant. And what about yourself?
I have a different perspective, and there are a lot of things happening at both the sector, public and private. So if I talk about government, we already have the NCAS, the National Clean Air Program, implemented for last 4 to 5 years. And now it is getting expanded outside the NCR, which is a hot topic every year, or I will say throughout the year, but visibly mostly in winter. So that is getting implemented. There is a continuous coordination between the state and the central governments to have the air quality monitoring stations implemented. Now we can see on the government website, you can see the real-time data for multiple locations. Now earlier I will say even in Hyderabad you had 2 to 5 stations. Now you will see more than 20-25 stations. So there is an investment from government, state, from private players getting this data available. Earlier that was not available. So you have to depend, okay, I can see the haze, it's polluted, otherwise it's good. So now you have data at a very various locations helping us to analyze. I see there is a growth happening into ventilation also. People are now accepting the issues, not only particles, but the humidity, the molds and other thing. So that is also getting wider acceptance that ventilation is important into the toilets, into the kitchens, into the household and office areas. So that is also growing with the standards or the commercial manufacturing license implemented in filters. We see that now it is also going to get more controlled industry into India. Like we got the Energy Star rating for the split ACs, room air conditioners. Similarly, we expect this to be happening to air filtration also. But down the line, 5 years, I'm confident that we will be improving on the indoor air quality across the India. But then I see there are much more efforts needed from the public and private side, especially on the awareness, on the investments, the funds required. So that's how we can drive the things.
Yeah, so the stick as well, the regulations and standards, and they breed awareness in of themselves as well, don't they? Like you say, weather stations appearing, it becomes a habit for people to look out the window and go, I wonder what it is out there today. It doesn't look very good. So that can only help. Gentlemen, I really appreciate you taking the time to come and talk to me. You've been very generous with your time away from your clients and contacts and conversations that happen at healthy buildings. So I appreciated it enormously. Thank you very much for joining me on the podcast. Thanks for listening. Before you go, can I ask a favour? Before you shoot off to whatever it is you have to do next, or even the next podcast, if you enjoyed what we've been talking about here, please do spread the word and let's keep building this community. And don't forget to check out our sponsors in the show notes. Ultra Protect, Eurovent, Erico, ACO, Farmwood and Zender, all amazing companies, and without them, this podcast would just simply not be possible. Check them out in the show notes at airqualitymatters.net, and do check out our YouTube channel. All this content is there, plus much more. See you again next week.